go.
When you do your videos of like those crazy intros, where it's just like the name.
I need to like something that comes in flames all across the screen. Nah,
You did a project for one of your classes.
right? That would be cool. Do it.
For your computer science class. Your 4th hour, so computer and lab.
It's not a video course, but
Okay.
it would be. I wouldn't be a bad idea. I know someone got some skills, right?
Hopefully. Aw.
Hey, truth is the truth.
Oh, good. Hold on.
Close that. Don't need that. Yeah, please do steal each other's notes. If someone writes something down, maybe you should too. All important. Okay? Alright, here we go. Slideshow from the beginning. Okay, cool. So, all the new people, are you guys, is this like, you didn't come from another class? Did anybody transfer from another class? Where did you transfer from? Then you probably already did this. You already did this, and you'll get to do it again. So, except here's here's the downside is chapter 8. We already did. We did that in December, so you'll have to get some help with that. They might kind of go with this, with chapter 6 a little bit, kind of building on that. So whatever questions you do have, please ask them, okay? Alright, so, like I said, this probably won't be the most exciting thing for you because this kind of combines a couple things that everybody's excited about. Please don't get nervous or crazy about it. Please ask the questions. The ideas are not meant to be difficult, especially when we're talking about and asking questions. Okay, man, this is full. You didn't get it. Are you good there, or did you pick that spot? Okay, I was like, man.
I don't like that.
It's okay. Hey, you know what? Where 2 people
So
eat,
congestion.
so can 4, okay? So,
Not always.
the more the merrier.
I thought you were gonna be like 2.
Unless we put a hole in the deal, right? Alright, cool. So, what we're doing is this thing called rational expressions. I think you already wrote that. What rational just means is the F word that a lot of people don't like in math, right? Which means fractions, okay? But it's not a big deal. It's going to be more of the stuff that you really did like, I promise you. You guys remember back then when they used to say that you would cancel, and I'm throwing air quotes out there for the video. Cancel stuff out. It's going to be the biggest thing that we really do in there, okay? We know that doesn't cancel out. It really just makes 1. Yay. Whoever said that, I think it's over here somewhere. So let's get started. Let's start by defining what a rational expression is. A rational expression looks like these right here. Okay? Even x to the 5th can be a rational expression because we can make anything into a fraction by putting that 1 under it, right? You guys remember that? How you turn anything into a fraction? Put a 1 under it. Okay, so those are all rational expressions. But mainly, typically, what we're talking about is when we have some function divided by some function. So some function over itself, where p and q are polynomials. And of course, biggest rule, right, the most important one, what can we not have in the denominator? 0. Okay? We can't have 0 in there. So we got to make sure that q does not equal 0. Or whatever that polynomial down there equals, it does not equal 0. Otherwise, we'll be working with something that we call irrational. Is it irrational? I forget. How did I forget? Man, I'm having a senior moment right now. I shouldn't even say that. I know some seniors that are. You guys know Mr. Shapiro, right? Yeah. He's an elephant, man. He never forgets anything. And if he saw this video, he's going to come tell me something about his weight. Watch.
Does he watch your videos? Wait.
He watches them sometimes just to find my mistakes, and then we talk about them.
Top
Okay.
subscribers.
I don't know. I don't even know how to check that. Okay, we're good?
No.
Cool, that's fine with me.
There's too many people in here. Why would he ask you about his weight? Oh, we're not.
Because he likes to mess around. Because I said he's like an elephant, he never forgets. But elephants are big and he's big.
Now he's definitely going to come asking you.
Well, he was going to do it anyway. Yeah, Mr. Shapiro, I know you. Alright, can we move on? No? And don't be consumed by writing everything down. I know it is nice that you write it down, but I guarantee some of you guys write all of it down and you never look at it again.
I do.
But then there's the video, right? You can always go back and whatever you missed. You can go back and do it.
Nah.
Read it. Watch it. Oh, I don't have mine narrated. Maybe I should.
Like and subscribe.
Leave your likes and subscribe.
I really tried for a semester and I'm so tired at this point.
I'm tired too. Like this morning, I snoozed the alarm 3 times.
Was it your math alarm?
Yeah, my math alarm.
Wait,
It was
you
like,
have to do a math problem to snooze?
yeah,
Oh, that's sad.
it does.
Wait, what happened?
Some of them,
You just answer math problems.
I've actually disabled the thing while I was still asleep. Like I've done them, and I don't know. Like the wife's like, "Did it even go off?" I'm like, "I don't know what happened. Let me check it." It was like already disabled. I did the math half asleep.
What was the
They're just,
Is it like
it's always like the sum of 2 numbers minus some other number. So it's like double-digit numbers, subtraction, addition. It's just arithmetic, so it's not that hard.
Still, I feel like I'd be awake.
I can look at my phone when I first wake up.
All right, here we go.
I know, I can't even read my phone.
Objective 2. Let's define rational functions and describe their domains. We already kind of talked about what a rational function is. It's when you got some function divided by some other function. And the domain of a rational function consists of all real numbers except those numbers that would make the denominator equal 0. Okay? So if you take a look at this example here, we could say, oh, the domain of that rational number is all numbers except for, well, what would make the denominator 0 in this case? What would x have to be to make the denominator 0?
5.
5. So it's all numbers except for
5.
5. Every other number that you put in there would actually work. It'd be okay. Now what would happen at 5 is you get something called an asymptote. I think that's not a new word for you guys, right? Okay, it just means some imaginary line that function never crosses. And it would never cross because x could never be 5. Can you see up here? Okay. Start from your good there.
I got a lot of stuff here.
Moving on. All right. So, taking a look at these here. For each rational function, find all numbers that are not in the domain. So, I guess the idea here is x can be anything in the top, right? So I don't really have to worry about it. Remember, the only time I have to worry about it is when this denominator becomes a 0. So the question is, how do I do that? And you've got a couple different methods to remember that solving for y business, or sorry, solving for x business. What are some methods we can use?
Substitution.
We're not working with a system, so we're not going to substitute. We could, if you want to substitute that, I guess I would call that like the trial and error. I just pick some numbers and see what gave me 0. One of the things that we could do is factoring. You guys remember that? That was actually lesson 6 or chapter 6. So what we're going to try to do with the polynomial down here is to factor it. And if you remember those skills, multiplies to 6, adds up to a -1, right? And that's going to be a 2, 3. Yeah? Negative, positive. Does that work? Does that work? Okay, so I can kind of think about this function as it being x plus 6 over x plus 2 and x minus 3, and then ask myself that same question. Okay? Well, what I have here is some number and some other number, right? So, the only way that this denominator, or this bottom part, could be 0 is if this number was 0. And what would make that number 0? If x was a value of negative 2. So, x cannot equal negative 2. Now let's make another assumption. Let's say this wasn't the 0. Let's say, and of course it's not going to work, let's say the other number, this number x minus 3, turned out to be 0. What would x have to be in that case? A positive 3, right? So that means that for f of x, x can be all real numbers except for negative 2 or 3. Because once I plug those in, actually in here as well, I would end up getting a denominator of 0. You guys want to check that? Let's check that, huh? Let's start with negative 2. What's negative 2 squared? 4 minus a negative 2 minus 6. What's a negative times a negative? Positive. So I've got 6, don't I? And what is 6 minus 6? 0. So there's the first one. We can try the 3. What's 3 squared? 9. Minus 3 minus 6. 9 minus 9 is 0. So those are the two cases where this would become 0 and therefore cannot be in the domain. Okay? That makes sense? Okay. I heard it. Okay, cool. Well, let's take a look at the other function on example B. F of x there, what would be in the domain, or what would not be in the domain? Sorry. What would not be in the domain? Britt?
Didn't you say 5 can't be?
For that problem?
Didn't you say 5 can't be down there in that other slide?
That was probably another problem, wasn't it? Let's take a look at which one you're talking about. In this case, huh?
Yeah.
But you see the denominator, what that looks like? This says x minus 5. So think of it, so if x was 5, it would be 5 minus 5 is 0, right? Making the whole denominator 0. So now let's go back to this example. Let's take a look at that denominator. Okay? So what cannot be in the domain? Maringer. In the denominator here, what number can I plug in? Sorry, what number cannot be in the denominator? It's just, there's only one, right? What is it? What is it? Why? Yeah, it would make it crazy. Like, bleh, not gonna, you broke math. Okay? You can't have 0 down there. So the question is, when we're working with a rational expression, that means one of these fractions, what do I have to worry about? The denominator. Correct? So, two weeks it was bad to me.
Wow.
I lost all that. Yes, I'm looking at you, smiley face. So, if 0 can't be in the denominator, he smiled when I said that, so. Oh man, hold on. Albert, no, it's not. Yeah, it is. Oh, good.
You said his name yesterday.
Yesterday was another day. I'm so tired and sleepy, like I'm not back in my routine yet. So Alberto, if 0 can't be the denominator, how do we make this denominator 0? What would we have to do to it? I would, right? I would have, but can I do that? Is there any place for me to do any of that business in there? No. There's no variable down there. There's no x. There's no place for me to plug something in. So can I ever make that denominator 0? There's no way I can do it, right? So what cannot be in the domain? Which x can it not be? Well, let's see what happens if you put 0 in there. 3 plus 0 is 3. Is that broken math? No, it's fine, right? So what number can't I put in for x? No, they're all good. They're all good in this case. No, it really wasn't a trick question because take a look here. It's just a 5, right? Is there any place for me to put something in to make that 5 change? No. So, am I safe? Yeah, I'm good there. Oh, dude, all numbers. You can put anything you want in there. Okay? So, negative infinity to positive infinity. All right, cool. Next objective. I want to make sure we understood this objective. What was the objective here? Figure out what you can't put in for x, right? And when do we have to worry about it? When there's variables in the denominator. And all we have to do pretty much is solve that denominator for set it equal to 0 and see what makes it 0, correct?
Yep.
All right. We'll probably end up doing more of those. Next part is that we want to write a rational expression in the lowest terms. Kind of like when you had 3/9. Did you ever just write 3/9 and get away with it? Maybe at the beginning, right? But then eventually, what did they want you to do? Simplify it. So that 3/9 had to become 1/3. That's what we want to do with our rational expressions. We want to simplify our expression so that it's in the lowest terms possible, okay? And the way we do that is that we figure out what the common terms are, correct? So in this case up here with the 3/9, that's really 1 multiplied by 3, and then I had 3 multiplied by 3. Oh, and I said, well, 3 over 3, don't say canceled out. 3 over 3 is 1, and 1 times 1/3 was simply 1/3. But we did that by finding that common factor, taking it out, and then simplifying it to a 1. Does that make sense? So, that's what this definition is going to tell you pretty much in math, or a very abstract language. Okay? It's saying, hey, you know what? If you have a over b, some number over some number, but there's some common factor in there, you can take that out, and that pretty much gets simplified out. Okay? I know it's not saying that, but that's what how you're supposed to read that pretty much. Okay? And that's not a decimal, that's a period. End of question. End of sentence. All right? We're okay with this? Or are you guys going to write this down? Yeah. All right, cool. Here we go. So here's what you're going to do. In order to simplify it, if it's factorable, do it. And then look for those common terms and then make them a 1. Okay? Apply the fundamental property. So here we go. Let's start with this example. Okay? So you guys are writing that down. For those of you that haven't been with me yet, I'm going to ask you to do something for me. Okay? Don't write while I'm writing or I'm explaining, because you're going to try to do both and you're not going to do either of them well. So watch what I do so you understand what I did. Then I'll give you some time to write it down if you need to, okay? Let's start with the numerator. Numerator, I want to factor that. I can see that's going to be y because of the y square up front. I'm multiplying to 3, and I want to get to 2. That's going to be a 3 and a 1. The 3 will have to be positive because that's a positive value in the front, and that's going to have to be the negative. And I can check that now. That's y squared. This is negative 1 plus 3 is a positive 2, and then my last ones is a negative 3. So there's my numerator. In my denominator, I've got that almost the same scenario, don't I? But in this case, I've got a positive 2. So the only way to get 2 is 2 times 1, correct? Now, they either both have to be positive or they both have to be negative. Because the only way to get a positive number is that they're both positive or they're both negative, right? So what are they? They're both negative. Bop, bop. Okay? Questions on factoring? Do you guys see the common term? So y minus 1 over y minus 1 has a value of 1. So now that it's simplified, it's just going to be y plus 3 over y minus 2. That's it. We're just simplifying fractions here, aren't we? I want you to try the next one. All right, cool. We're done? All right, cool. We're done.
What? You just had to start.
And now we're done.
Okay.
Do you remember why?
Oh,
Why? Go ahead and say it, Calibre.
don't ask me.
Oh, I thought you would. Oh, like.
Kayla said,
No,
oh.
I was joking. I don't know. Explain.
Storm?
It just says that you want to hear. It's just y plus 2 because y squared plus 4 is the conjugate of y.
I like where you were going. That's good. That's good conjecture. Fancy word, huh? Do you know what conjecture is? Math people wanted their own version of hypothesis.
Really?
So conjecture is simply a hypothesis, but it's the math one. We wanted to be cool too. You were trying to factor this, right, Storm? And that's kind of the thing we were talking about in chapter 6, is that you cannot factor the sum of squares. Okay? Let's try to do that real quick. Okay? Because I remember you were talking about the conjugates, right? You said that would be like y minus 2 and y plus 2. That's how you would factor it, correct? If from what you remember? So let's expand this and see if we get this back. Because that's what should happen, correct? If I multiply these, I should get this bad boy back. So y times y, there's my y squared. This is going to give me a positive 2y. This will give me a negative 2y. Oh, it's looking good because that's how much? 0, right? 2 minus 2? 0. But look what happens at the end. What's a negative 2 times a positive 2? A negative 4. Okay? So, like I said, that was a great conjecture. But the sum of two squares cannot be factored. It has to be the difference of the squares. Okay? Now, if it's cubes, yeah, we got formulas for those. But not with the squares, okay? So try to get that memory back. Go back, look at those notes. So if I can't factor this denominator, then how do I simplify it? Well, I don't, do I? Okay? But here's a question for you. What's the domain? Remember what we did in the last objective? What cannot be in the domain? Okay. Well, I can't factor it, right? So can I figure out what can and cannot be in the domain? Yes, you can. Okay, because remember, what do we want to know? What can't this denominator be? It can't be 0. So we're going to use our algebra skills when we're going to ask this question. When does y plus 4 equal 0? Does everyone understand the question I've just asked here? When does y squared plus 4 equal 0? And what would you do? You'd be like, y squared is negative 4. Take the square root of both of those, right? Y equals, what is it? 2y? Are you ever going to plug in 2y? No, so then you're good. So, you can put any number you want in there and you're still good. Okay? Because the only thing that might have had a chance would have been a negative 2, correct? But what happens when you square negative 2? It becomes positive, doesn't it? And now you have 4 plus 4. Questions? Is it too much?
Just a bit. I'm joking.
It feels like it's changed, huh? Doesn't feel like the same class?
No.
No.
It feels it's okay.
We
We
never
welcome you
write
though.
this
We're
much.
not hating. All right, cool.
We're definitely.
Can we simplify this problem?
Yes.
Can we simplify this problem?
Didn't you say yeah because it's a cube?
This one is simplifiable, okay? Because it's cubed, so we can factor it even if it is the sum of cubes. You guys have the formula? You guys remember that bad boy?
No.
No, not at all.
Let me put the formula up here. It's going to be the first one plus the second one. First one squared minus 2fs plus s squared minus 2fs. Yeah?
It's first plus second, first square.
Who has their formulas from the last?
Yeah, I don't.
Nobody has their formula? Oh, do I have my blank book? Hold on.
I bought a whole new notebook.
I have a math Bible.
Oh my god.
Well, you have to do math problems to wake up, so.
If I could find my zipper here.
When you set up like
I
we
do
ever
have
read
it
this
with
much
me.
last semester.
Josh, you still have yours?
You have one?
Yeah. Why don't you? You should. Look. Math.
Wait,
math,
these are notes?
Math. Yeah. Actually, these are all formulas.
Why is this a small little notebook? Oh my god, I need this.
I don't know if it's 2fs though. I don't think it's a 2 in there. I could be wrong. I'm trying to find.
Oh, in a different year?
Everyone
did
had
you-
to have. I requested that everybody did it.
Why did you make us do it? I know.
She's like,
I don't know.
this year though.
He's not questioning something.
What's life now?
Huh?
She was unprepared.
All right, hold on. Where are you?
Honestly, it would be helpful.
Yeah, because I
But
don't
it's
remember
a little
shit.
late
This is
now.
all statistics.
How come you did that with your other classes now?
Because he
You're not
doesn't
like
know.
us.
Yeah, I'm not bad.
You know, we all failed your finals.
I got 4.
You only got 4 right? Yeah. What were your fast
Integration plus calculus.
of the final?
See, if I would have these better organized.
You got 4 right? And we got 4 right and there's no 3 thing.
Here we go, algebra.
Why not 4 out of 20?
Yeah, there's no 2 in there.
It's fine.
There's no 2. There's no 2. So there you go. Okay. So, you guys ready? Welcome back. Welcome back.
No.
So let's factor this. In this case, 1 is the first and p is the second, because 1 to the third is still just 1, correct? If I go 1 times 1 times 1, it's just 1. So I can write it as the sum of 2 cubes. I can write it in this form. Okay, and that would be my factoring formula. So when I factor this top one, I would have 1 plus p over the first one squared. What's 1 squared? 1. That's a plus. I'm going to go minus p plus p squared. And that's going to be over 1 plus p. What simplifies? The 1 plus p is going to simplify. That becomes 1. So 1 times this polynomial means that's the polynomial we have left. Yesterday I was reading over, I kept saying polynomial. You all right, Brooklyn? Easy stuff, huh? Got this.
What? We still have 100 days till we graduate?
No, it's just the 100th day. It's been the 100th. You have like.
No, like they mean like Saturdays, Sundays.
Yeah.
Oh, counts those.
Still say more?
We should.
Graduate.
Okay. Be very careful. Because this is a very common mistake. You guys see how you have the 2 and the 2 there? People want to say, oh, that's just the 1. But you can't do that. Because y minus 2 is some number. It is some number. And when we make those 1s, it's because they are factors. That means they were being multiplied. Okay? So take a look. See how they were always being multiplied? It's this times that. Can I go back another? This times that. So that's what got simplified. I didn't go after this one because that's part of this polynomial. Okay? Now, if there was another 2 sitting up front, out here, then I could say, oh, that's a 1. But not when it's like this, okay? Wholeness. Okay, again, so let's write these in the lowest terms.
This is more notes than we took all year.
Whatever.
I swear.
You're
We
tripping.
didn't take as much notes.
You are tripping.
Well, you didn't take notes last year.
I'm
Stop
It is
it.
last year.
It is last. That's what I meant. Like you said, you never took notes. Cause it like.
Well, that's what she's saying. She's saying she's taking notes now, so it's more than she's ever taken before.
I took notes, but just this is more than we ever took.
No, we've done a lot.
We did.
There's been some sections where even I was like, oh,
Get
They-
the notebooks.
I kind of threw it away.
ouch.
Oh, I think I might just stuck it in my desk, but there's no promises that it'll ever go back down.
Yeah, I know my notes.
I think I threw.
I still have all my notebooks from like freshman year.
I have some from college.
Why?
I'm not a board.
Wait, which one are you?
Oh no.
Why?
I don't know.
There's a mentality when you're going to be a teacher, like, oh, this is cool. I might use this when I become a teacher.
You
So,
never use it.
so you start hoarding stuff that you might use when you become a teacher. And then when I finally got into the classroom, I did dump like all kinds of stuff, like recycled it. But then again, those notebooks, they just felt nostalgic, so I didn't get rid of
You gotta go with those away.
them. No, I'm not doing it.
Where
Do
are
you,
they at?
do you like read them when you're at home?
No,
Then
who
what's
reads
the point?
that?
You do.
Yeah, I do.
Then what's the point of keeping
I have read them.
Wait, where are they at?
Ew.
In a box in the garage.
They're in a
No,
box.
they're
They're
probably
not in the
like
garage.
bins,
They're in my office. You guys struggling here a little bit? Because they're not the same, huh? You guys see that? They're not the same. Because if I try to change this R minus 1 up here, and I try to put it in the same order, because you want to see, everybody wants to just look the same, doesn't it? So you try to switch it around. That's a minus R plus 1, isn't it? What? So what I can do, so here's how I'm going to fix this denominator. I'm going to factor out a negative 1. So it's going to look like this. It's going to be R minus 1 over, I'm going to factor out a negative 1, and that's going to make this R minus 1 in the denominator. See it? If I take out that negative, doesn't that become a positive R? And that becomes a negative 1?
Sure. Not very
David, you see what I did? Does that make sense? Okay, so what can I simplify now? The R minus 1s, what am I left with? Negative 1. Which is just negative 1, right? Yay. Oh, man, that gingerbread was bomb. Jake brought me some gingerbread after school. When was it, on Friday?
Yeah.
Oh my goodness,
Friday.
that stuff was
You're
amazing. I have to ask, is it homemade?
Yeah, it is.
Oh my goodness, that was amazing stuff. It was gingerbread. Like I thought it was pumpkin first
Why did you just randomly think of that?
because I saw Jay. I wanted to thank him yesterday. You should. You don't know how much I enjoyed that. That was so
He's
Good.
just sitting there crying because he's so good by himself. Reading his math books at It's so great, I need to thank Jake.
You got me.
It was probably that math problem that like
It wasn't coffee, it was on the first one.
Okay, it's time
I don't even want the kids to touch it. Like, no, you can't have the.
You like this is all mine?
I shared it eventually though. Alright, cool.
after you eat them.
Let's do this last one. We'll wrap it up here because we're almost out of time.
Yay.
And we'll continue at quotient. So let's do this one real quick. This is going to have the same problem as the last one, okay? That denominator doesn't match up as far as signs are concerned. So if I do this, I'm going to have to go negative p squared. Actually, I take that back. I can't change that sign yet because I won't be able to factor it. But if I factor it in this form, which is 2 minus p and 2 plus p, then I can go ahead and cancel it with this one. Okay? But what would that leave me here? That negative 1 on the outside, right? Okay? So when I take this, and I'll write it for you, this would be a negative, negative 2 plus p, and the other part would stay 2 plus p. Then I can simplify this with this, and I would get negative 2 plus p. Okay? Class is over at 9:10, right? Yeah.
Are we going to do the homework like you gave us last night, or are we going to have math lab again?
Don't do math lab.
No, I kind of like the videos. I didn't mean right now, I meant like be able to read the scripts.
No, you'll have math lab.
Tonight?
Or tonight.
Wait, are we going to do the videos? Are we going to finish those?
Yeah, tonight.
So that's our
Finish them? Like how many? It was like an hour.
Tonight it's only 3 more.
There's-
An hour.
there's 4 of
6?
them.
Yeah, for all of them.
There's 4 of them
Yeah.
that are left.
There's 4 left.
You did 3, and then there's 3, and then at the end it's like the.
Do 2 of them tonight. Okay?
4 and 5.
Let me go ahead and end this real quick. Thank you, because we're going to run out of time. Thank you, sir. Appreciate it. Berto.
My luggage.
What website is it?